Good job making it to this point. You seem to have quite a bit of persistence on your side. You have now made it to the climax of the series. I will split this into 2 videos, I think. I'll cover some simple stuff here, and then I'll go into some more advanced topics in the next one. First, I'll explain why queries exist and then how we can use them. As we already know, in Flex, you can create entities with various attributes, such as components, tags, and pairs. We can use these to group entities together. Let's focus on components first, and let's create 3 entities, E1, E2, and... actually, I haven't used a Hytale reference in a minute, so I'm going to make them Quebec1, Quebec2, and Quebec3. I'll also put a name on them, just so you can tell them apart. I will also make a position and elder component. Let's add the components to the Quebecs. By the way, you can add components by simply using ECSSet. You actually don't need to call ECSAdd. Notice how the second Quebec does not have the elder component. This will be important to keep in mind. Right, now for the main course. Write ECS query t Quebec query equals ECS query, and then put in the world, and then some curly brackets. Then, in the curly brackets, put in terms, and then the terms are going to be what we're going to be searching for. In this case, let's look for an entity in the world that has the position component, like this. Now, remember what I said about components being entities in the last video. This is where it's actually useful. ECS ID position gets the entity that we call position. We create this entity when we use the ECS component method. Essentially, that means that Quebec 1, 2, and 3 all have an entity attached to them called position, and that's what we're looking for in the query. After running this query, we know we will get all 3 of the Quebecs back, because all of them have the position component. Let's do the same for the elder component. Now, we are looking for entities that have both the position and the elder components on them. This time, we will only get back Quebec 1 and Quebec 3 because the second Quebec does not have the elder component. As great as it is letting me tell you exactly what the result of a query will be, why don't I teach you how to actually iterate the query? If you actually want to be able to use the results from the query, we can iterate through each of the entities like this. This is an iterator. It essentially holds the response from the query, and we can use this to iterate over all of the entities that match the query's terms. If you write this, we can cycle through all of the entities now. First, we write this while loop, which iterates through all of the types. Don't know what a type is? I'll explain it quickly. Types are defined as a group of the entity's components, like this. Position and elder is a type together. Position is a type on its own, and elder is also a type on its own. That's all they are, and in this case, we are only iterating one type, which is position and elder. Okay, now let's actually iterate through all of the entities. We can use a for loop to go through all of the entities of this type. We can do whatever we want with the entities from there. Now, you probably want to know how to use the components on the entities. Well, for this specific example, we can write this. Pay attention to the way we set up the query. Notice how position is the first, and then elder is the second term in the list. That mirrors what we have written here when we get those components, hence the 0 and 1. If we flip the terms, we also have to re-specify which component comes first. We, again, can use them however we want after this. Here's an example. I know it's quite a lot of code to look at, but just have a stew on it for a minute. It'll come to you. Okay, hopefully you took a bit of time to look at that. Now, access modifiers. If you come from object-oriented programming, you will probably know the term encapsulation. You know, public, private, protected, all of that. This also exists in Flex. Say we want to be able to read the elder, but we don't want to be able to write it. This is very easy actually. All we have to do is put .inout equals ECSIn next to the term we want to make read-only, and put const before the line where we got the elder component later. Alternatively, you can use ECSOut if you only want to write to the component and not read, ECSInout if you want to both read and write to the component, this is the default, and ECSNone if we don't want to be able to read or write it, but we want to make sure that the entity at least has the component. I'll tell you what, I think that's enough for one video. everything I mentioned here is going to be what you will use 90% of the time. But just in case, I will make a part 2 explaining some of the more complicated queries, such as change tracking, caching, variables, facts, and anything else that I might find useful. I will see you then. Good night.